over here, we've got a question that involves your trig compound angle formulas, and then you want to sort of apply that to a follow-up question, asking you to apply that to a particular triangle. So let's get part one out of the way first, which is just a nice, simple trig identity that you should know, and that gives you basically your sums to products relationship. And then you want to then show this. So keeping that in mind, let's do the first part. We'll just write it out here actually, because it shouldn't take very much. So to do the first part, it's very simple. You just expand. So part one, sine of alpha plus beta is sine alpha cos beta plus cos alpha sine beta. We're aware of that. Sine of alpha minus beta, this is going to be sine alpha cos beta minus cos alpha sine beta. And then just add them up. So sine of alpha plus beta plus sine of alpha minus beta. You can quite clearly see that this just cancels. Over here, these terms cancel. So you end up with 2 sine alpha cos beta. These just double up. And that's the part one. Quite easy. And there's your 1 mark. Now you're asked to find that if alpha, beta, gamma are the angles of triangle ABC, and sine gamma equals 2 sine alpha cos beta, show that they have 2 equal angles. So let's get rid of that and give ourselves a nice diagram to see what's going on. Just draw yourself a general triangle. And you've got alpha, beta, gamma, which I will assume it's like that. Now you know sine gamma equals 2 sine alpha cos beta. Now, this probably is going to be a little bit helpful because remember, this is part two, which really means you really should be thinking about how you might use an earlier part. And you might want to think about your diagram, but right now, let's focus on just your earlier part. You might want to think about how you can use the earlier part and maybe do a bit of close inspection to see how it might be relevant. That's probably a bit of a hint there. So it would appear this question is strongly hinting at you might want to consider the fact that sine of gamma is the sine of alpha plus beta plus sine of alpha minus beta. That might be helpful. I mean, they've written it in exactly the same form, so that might be a bit helpful. Now, you're trying to show that it has 2 equal angles. So you're not really told which angles are equal, but you want to basically show it's isosceles. So basically either alpha equals beta or, alpha equals gamma or beta equals gamma, one of them. There's a pair that are equal. So you might want to consider which pair is equal, but we also know as well that they're a triangle, right? So we should also think of what the sum of the angles are. I mean, alpha plus beta plus gamma, it's in a triangle. It's going to equal 180 degrees. But in that case, that means we know what alpha plus beta is. We can get an expression for alpha plus beta. That'll be 180 minus gamma. And this might be very useful over here. And now you might want to think about what sine of 180 minus gamma equals. And we've done identities before where you try to simplify. So sine of 180 minus theta for any angle theta. Well, if you think of it as acute, even if it doesn't have to be, it's going to be positive because it's in quadrant 2. It's going to be sine because it's 180. So it's just positive sine theta. So in other words, this is just sine gamma. So in other words, sine gamma is 2 sine alpha cos beta, because this is given. Let's write in our reasons, right? Which must equal this because of part 1. Which must equal this because, well, angle, sum, or triangle. Which must equal this because, well, trig identity over here. But then think about what you've just done. You said sine gamma equals sine gamma plus sine of alpha minus beta. Like this whole thing was sine gamma to start with. And so for sine gamma to equal sine gamma plus sine of alpha minus beta, the only way that works is if sine of alpha minus beta must equal 0. But I mean, alpha and beta are both acute angles. Well, maybe not acute angles. They could be theoretically obtuse angles. Well, they can't both be. Well, you can see right now without thinking about it too much. They could be acute or obtuse. They can't be reflex angles or bigger because they're in a triangle, right? But for the sign of the difference to equal 0, that means the difference between them must equal 0, or theoretically 180 degrees, 360 degrees, ... But there's no way if for two angles in a triangle to have a difference of 180 degrees. It's not just any angles, they're angles in a triangle. So therefore, alpha minus beta equals 0, which implies alpha equals beta. Which is another way of saying two angles are equal. So not only do they have two equal angles, but specifically alpha equals beta. And basically by just following what the question has given you, and this is a good example of the question not being too difficult. Part 1 should be quite simple if you know your trig identities. And if you don't, you can look up in the data sheet and then use them. And then this is just a good example of a question that is not, I wouldn't exactly call it standard, because you don't get this type of question in every single paper, but it's an example of how you could just follow the breadcrumbs that they've given you. They've given you sine gamma equals that. You can note that you can use part 1 to do that. If you're given that, you can use part 1 to convert that. Once you've got part 1 to convert that, then the next part might be a little bit tougher to come up with, but you draw out the triangle and see what you get, and then you follow that through, and ultimately to get prove alpha equals beta, which is what you're trying to prove. That is, two angles are equal. And that's how you do the question.